All right, in this video, we're going to investigate Ohm's law. So what Ohm's law is it relates voltage, current, and resistance in a circuit. And so conceptually, the best way to understand Ohm's law is that current is equal to voltage divided by resistance. In other words, if you have more voltage in your circuit, you're going to have a bigger current. Because as V gets bigger, I will get bigger. But as you have more resistance in your circuit, your current will drop because there's more again, resistance to the flow. There's more things blocking the flow, so the current will drop. So this is the best way to understand the relationship of Ohm's law, but it is not the best way to work with it mathematically. The easiest way to work with it is in this more common form, V equals I times R. This makes things a lot easier. So all we're doing in these problems is we're starting by writing down what we know. We know the voltage is 8 volts. And it's a little confusing that you write V equals 8 volts. It's all about context. This V on its own stands for voltage, but this V with the number stands for volts. It's a little confusing. But anyway, so the voltage is 8 volts. The resistance in this case is given to us as 40 ohms. That's a Greek letter. So we're looking for the current. We don't know what that is. So we're going to start by placing these, substituting into this equation. So V is 8. And by the way, this works for volts, ohms, and amps. If you have other units like millivolts or milliamps, you have to do a conversion first. This video is not going to get into that. We're just assuming that we have the proper units. So anyway, voltage is 8. The current remains unknown, so I'm going to leave that I, and the resistance is 40. So here's my setup. I just plug in. I want to get I by itself, so I divide both sides by 40. So 8 divided by 40 gives me 0.2. So I'm going to get I equals 0.2. This cancel over here. And current is measured in amps, so that is my unit. So this is the current passing through this circuit. It's always a good idea to check and make sure you didn't make a mistake. So this equation we know is true, V equals I times R. Does I, 0.2, times R, 40, give you 8? And it does, so this checks out. So it's always good to do that last check. So that's how we use Ohm's law. Let's do one more. So here I have a situation where I have batteries. I have 6 batteries, and each one has a voltage of 1.5 volts. So if you hook up 6 batteries in a row in series like this is how most of your devices do it as well. The voltages add up. So again, I'm 6 batteries, each one's 1.5. So you have 6 batteries times 1.5 each. That means the total voltage of the circuit is 9. So we had to do a extra step there, but it wasn't a big difference. The voltage is 9. It tells us the current is 0.1 amps, and we're looking for the resistance. That's unknown. Our equation is V equals I times R. So we're going to plug in 9 for V. We're going to plug in 0.1 for I, and we're going to leave R here. So that's our equation. How do we solve for R? We'll divide both sides by 0.1. So 0.1 divided by 0.1 cancels. 9 divided by 0.1 is 90. So the answer is 90 ohms is what R is. And again, just check your work. Does 90 times the current 0.1 equal 9? And it does. So checking our work, we did our math properly. This works. So that's really all there is to Ohm's law. It's a very it's one of the more easier mathematical things that we will do. There's not really any fractions involved. It's just using this equation and solving for the unknown. So until next time, I am Derek Genova. Have a delightful day.